one thing waiting for you. So here are what I had on the board before. Our criteria. I wrote the weight percent, even supposed to be weight as fractions. I want to have it as fractions so that the sum product works, but I want to show it as percent. How do I do that? You type it as fractions, and then you select the fractions, and right-click, Format Cells, and you select under Format Cells, under Number, Percentage. Percentage. Okay? Let me please decrease the decimal points to 0. Okay? I selected as number, percentage. And if you select percentage, it changes to percent. Internally, it's fraction, but it shows now percent. Okay? So, the weighted value, the weighted valuation of each of those candidates is going to be our sum product command. You can do it without sum product command by putting extra columns, but it's very convenient and presents the results very succinctly if you use the sum product command. So those guys, comma, this. And let me do something else. Let me do it so I can copy. So this would work for the first one, but I have to retype the sum product for every one afterwards. If I change the first column to global address instead of to absolute address, sorry, absolute instead of relative address, when I copy the cell to the right, I will have the right formula. So I want to put dollars to make absolute addresses on the base and leave relative addresses on the C's. You follow me? If I make the base absolute addresses, so what I will do, I'll click right here and press F4, and click like here and press F4. On Macintosh, it won't work like that. You just have to type $.
Is it Chick-fil-A chicken nuggets?
But, so, I'll click here, and I'll press F4, changes to the dollars, and I'll click after B7, after the 7, doing the 7 and the comma, and I'll press again F4. And now I have a formula that I can copy to the right. Enter. So the first one has 3.6. We copy to the right. These are the results. So, which is our winner?
C.
C is the winner. Okay? All right. So I have until 6:25. Sorry, that's 5. 6:15, 50 minutes. 6:55, right? No, 7:05. I have until 7:05. Yeah. All right. So let's do preliminary simulation, first steps of simulating the winning process. Okay? So I have two reactions taking place. The first reaction takes ethylene and converts it to dichloroethane. Reacts ethylene with chlorine to make dichloroethane. And the second reaction cracks dichloroethane to make vinyl chloride and HCl. So these are the two reactions I need to model, and I have some specifics for them. 98% conversion, on the first one, 60 to 65, I don't remember what I normally use. I don't know. I'll use, I guess, 65. So let's start unison. save this. So everybody clear how you make screening and scoring matrices? Okay, and by the way, click on one to make sure that you go right. You see some product of those weights with those, that's correct. All right. So let me close Excel. And well, let's see that. So this is not homework. Okay? This is not something you're turning in. But if you have your laptops, you might want to do it together with you. Okay? So file, new case. Enter simulation bar. No.
You gotta add it.
I meant to click add. Okay, we need to add our components. And we have, of course, ethylene. Do you remember how we get ethylene?
Ethene.
Ethene. Okay. And we need chlorine. CO2 will do that. We need ethylene chloride. Ethyl chloride, dichloroethane, okay, which is C2H4 chlorine 2. On this, let me go with the chemical formula. So I'll type C2 and probably C2H4 chlorine 2. Giving nothing. Oh, wait a minute, it puts some.
Oh, that's right. It just has a weird name.
That's right. Let me delete it and go again and see what it is. Okay, remove.
I didn't do it.
No, that wasn't you at all.
I don't know why I looked. I hate you.
I'm kind of curious.
I guess we'll do okay. I cannot think of anything else that can be.
Is it next master 1?
C2H for chlorine 2 cannot be anything else. And that's the only choice we're given.
If you try to make
No, there are two.
it's like we're just like 100.
Okay, the 1-1 or the 1-2, which one do you think is happening?
The 1-2. I put the
Right,
1-2.
you're breaking the double bond, right? So one chlorine will go in the one position, the other will go in the two position. So it should be the 1-2.
Oh, thank God.
Okay, so select the 1-2 chlorine C2. Okay. Next.
1-2.
And by the way, you can sort the list. So let me put the reactants first there. So I will sort it. Something should play a role, but I can move the chlorine to. Okay, so I move them both, change the order. All right. Of course, this now cracks to give vinyl chloride. Let's go back to full name synonym. Vinyl chloride could work. And HCl.
Wait.
I have to put it the wrong position. Okay, I'll remove it. In some cases, the position matters in some calculations. It shouldn't be, should be probably bad, but in some cases it doesn't matter. So add vinyl chloride here. Yeah, well, okay, so just leave it. And finally HCl. So those 5 components is what we need. All right? And let's use the simulation package we're going to be using in the project. I want you to get used to using that. So there's no OK or anything done. So what do we do?
Yes.
X fluid packages. And the one you need to use for your project is general NaTl with ideal gas. So add, go alphabetically to find general NaTl. And select ideal gas, that's fine. And we're done with components.
Oh, hold on.
You see 5 components.
Nope.
Need to click back again. Package is this, and the components.
We were gonna be graduation buddies. Forever.
These are the 5
Because
components.
I'm gonna graduate again.
Anybody need more time? All right. Wait for that. By the way, if anyone figures out a way to blow this up, to make
I looked it
run-
up. Command plus plus.
It works on this?
I don't know. I looked it up. I have it right in front of me. Command or yeah, Control plus plus.
Or control plus?
Please work.
I don't know. But let's try. Try it.
Oh fuck, that's what it says right here. Control plus plus increase font size.
For Unison specifically?
Yeah, of course I looked this up. Yeah, it's right here. Look.
It says unison.
Yeah, it says
Yeah.
Unison.
Okay, let's try it.
Maybe try
Maybe, like,
selecting
click
just
just
the
the
box.
window?
Yeah, check the box.
Click just the window.
Without
Yeah.
selecting a component. Just like-
Yeah, click on the window.
Click on the window instead of the component. Like
Oh, yeah, the PFD, but that's not what I want.
no, I'm talking about like hit component list or whatever. Just like
What do you want to do? Hit
just
here?
hit there.
Yeah,
Yeah,
click
now
there.
try it. Oh,
It worked.
Then
Yes.
Control plus plus.
I mean, it technically did.
It did, yeah. Woo!
What did how did I lose it? What did I do now, guys?
No, you just expanded
You
it.
made it bigger. What
Just
you
made it
wanted.
bigger. You can go back to just the window.
All right. Anyway, okay. Okay, you want me to click here? Okay, control.
Plus.
Plus plus.
Nothing.
Damn it, I googled it too. I took the time.
Let's put the non-slow. Double down.
Yeah, try Windows Plus. Maybe.
Doesn't work. I put
Damn.
some mine in this.
Try
Those
it.
were made.
1 point for effort.
All right, let's continue. So, everybody, okay, ready for the simulation environment? So, enter simulation environment. Get a warning, that's fine. The warning means that some
What?
pictures are taken as ideal means. All right, let's first enter the reactions. And in this case, I'll put them in 2 different reactors because I have different conditions. So before we modeled 2 in-series reactions in the same reactor. But this happened in different reactors, obviously. One is at 90 degrees C1 atmosphere. The second reaction is at 500 degrees 26 atmosphere. Obviously, they're not happening in the same vessel. So they'll be modeled separately in 2 different reactors. So, let's go to PFD. Sorry, do flow sheet. Reaction package. Reactions, add reaction, conversion. Our first reaction is ethylene plus chlorine gives us the 1,2-dichloroethane. Coefficients are, question? Oh, slow down. Thank you. Yes.
So when you do have stuff on the PFD, you can zoom that box plus. You see the plus sign?
Yeah, that plus works, I know.
Oh, okay.
But it doesn't affect the letter size. It changes the size of the picture.
Okay, I wanted to make sure you have that.
Yeah, that I'm familiar with.
No. Oh.
What I want to do is change the size of the window so people in the back can read more comfortably. If someone can find a way I can do it.
It's ideal gas.
Okay, so coefficients, -1, because we would have 1 mole of ethylene, 1 molecule of ethylene reacting with 1 of -1 for chlorine, and we get 1 of the dichloroethylene, of the dichloroethane. And you can see this is an exothermic reaction. You can see the heat of reaction. Okay? And of course, we're not done. Base, of course, is going to be ethylene. And for this one, we had that the conversion of the first step was 98%. So I'll go ahead and put 0.98, right? No, good. Hopefully this class, nobody will mess it up. It's 98. All right? And now the reaction 1 is ready. Let's add the second reaction, reaction 2. This one will have components. It would be, first component, the reactant is the dichloroethane. And it breaks into 2 products. One product is vinyl chloride, and the other product is HCl. And -1 for the reactant, and +1 and +1. And what signs does the heat of reaction have the moment I press this one? Positive. Indeed, that's an endothermic reaction. Okay, cracking is endothermic. And bases, obviously the reactant. And we have 60 to 65%. Well, let's make it 63%. So 63, not 0.63. And our second, yeah.
Can I see the
-1 for the reactant, 1 for the 2 products. Zach, question or? All right. 63. Conversion, I put 63. The text says 60 to 65, so I put 60. All right. All right. So, they're going to go in different reactions. A reactor takes a reaction set. So I'm going to define two reactor sets. So, with me everyone? So, new set, let's name that reactor 1. And go to active list and select reaction 1. And that's it. That's the only reaction that will be in reactor 1. X that. Type another, click again, new set, okay? If I need to slow down, tell me. New set. Call this reactor 2. And go to active list and select reaction 2. By the way, if you make a mistake, you have to first move it to inactive and then you can delete it. You cannot delete something from active. Okay? Finally, what reaction sets? Notice the global reaction set includes all reactions. So, what sets do I want to make available for my simulation?
Reactor 1 and 2.
1 and 2. So add set reactor 1, add set reactor 2. So that completes our reactions. Now, we want to make, if I remember the problem statement, we want to make 800 million pounds per year of vinyl chloride, right? So, I will move, here I have 2 reactions happening. I have to move backwards. I will move backwards from 800 million pounds per year with a reasonable operating factor. Let's assume again, like a new project, 90% operating factor, okay? And first I'll figure out how much